All right, let's generalize a little bit this idea of forward trig function applied to inverse trig function. Let's go back on the picture to the unit circle, and let's go back to the first quadrant to make it a little simpler. Okay, and let's look at what if you have sine of inverse cosine of x. We want to just, it's nice to have a master formula for this sometimes, especially when you use this in a more advanced application or put it in calculus. And it's just going to be summarizing what happened for a problem like this. Okay, so we're just going to do everything with a letter, but it's not really going to be a lot harder. So once again, we're just going to name the inside thing, but without thinking that means we have to calculate it exactly. And then just say, well, what does that mean? Cosine theta is equal to x. Okay, so whatever this number is, like before it was like 2/3 or something like that, it means cosine theta is equal to that number. Okay, and we want sine theta. Okay, let's write down Pythagoras. Again, I'll come back to the unit circle to be in the most simple, basic case. Sine squared theta plus cosine squared theta equals 1. And guess what? We know cosine squared theta. Remember, the assumption is x is something that we think of as a known quantity, and we want this in terms of x. So what we really want this is a formula, a simplification in terms of x. Okay, we're almost there, because we can solve for sine squared theta and then solve for sine theta. It's going to be 1 minus x squared, and then take the square root. So probably need a plus or minus here, although we'll consider that in a second. Okay, so we're almost done, but, well, there really should be a definite answer for this. Given an x, inverse cosine is a very, very specific choice of theta that satisfies this equation. It's the simplest one. And then sine is unambiguous. It's going to be a definite answer. So this really plus or minus shouldn't be here. And let's think about the quadrant information. Remember, cosine theta is equal to x, but we also know theta is between 0 and pi. That's by definition what inverse cosine values are. And that's exactly where the sign is positive. Awesome. So something that could have been a plus or minus, or really kind of some annoying rule, depending on what x was or whatever, it turns out to be wonderful. And so sine theta is root minus x squared, and so the punchline is that sine of inverse cosine of x is root 1 minus x squared. There's something very interesting here. These functions don't cancel each other out. They're not a function and it's the inverse of the same function. So we don't expect just x here. But what has canceled out is the trig is canceled out. The answer is just algebra. Leaving, this is not working very well. Leaving just algebra. Okay. That's very, very cool, and it actually has some real important consequences later on in calculus. That what happens here is that you've got a complicated formula, but the trig is canceled out, leaving just algebra. And what algebra is it? It's really Pythagoras in disguise. When you've got like square root of sum or difference of squares, that's Pythagoras. And of course, that's where it came from. It came from Pythagoras, which was up here. Okay. Let's look at one more example of that. Now suppose I'm putting in y in here. You don't have to use y, but I'm taking the inverse sine of something, and so it makes a lot of sense to call that variable y, because y is going to be a height. So what is this guy going to be? Once again, let's just use theta as the name for that that angle. And so that means that sine of theta is equal to y. So again, that looks a little weird. Like, what does that tell us? Well, you want to think of y as really a stand-in for a number. Y as a known quantity. And we just want a master formula that no matter what that number is, it gives us a shortcut for doing the procedure we had before. Okay? Because notice, this is a massive shortcut. You don't if you memorize this, you really don't ever have to do the procedure with the triangle again. Most people like the procedure with the triangle instead of memorizing this. But if you memorize this and all of its variants, like down here, you could just put in, hey, I know that's root 1 minus x squared. I know the trig cancels out and it leaves a particular algebraic formula. Most people don't do it. I don't do it. Not usually, but you can. Okay, so back to this one. Sine theta equals y. And so let's see what we get. We want to figure out the cotangent. Ooh, that's adjacent over opposite. That's x over y. So we're certainly going to need x. Okay, so we're going to need the cosine. So we still have cosine squared theta, or sine squared, plus cosine theta squared theta equals 1. Okay, now it's the y that's known. Y squared plus cosine squared theta equals 1. So cosine squared theta equals 1 minus y squared. This is very familiar. And cosine theta equals the square root of 1 minus y squared. Now, is it plus or minus? Well, again, sine theta equals y, and because theta is the value of an inverse trig function, it's in this region from minus pi over 2 to pi over 2. That's exactly where the cosine is positive. Boom. No plus or minus. We're good. Okay? And now what's cotangent theta? It's adjacent over opposite, or just cosine over sine. And we're basically done. Because we now have formulas for those guys. And so it's going to be root 1 minus y squared. I want to come back over y. And we're done. A little more complicated formula, but we're done again. And once again, the trig has canceled out completely, leaving just algebra. That's a little more complicated, but it's still basically Pythagoras type algebra.